So, hello everybody. Thank you all for coming, both of you. Yeah, it's a private session. So, this session is about reactive extension and specifically how we can use reactive extension in order to test time-based and concurrency type of operation inside a modern application. And I wonder how many of you have heard about reactive extensions before? No one. Okay. So, that's okay. We're gonna talk what is reactive extension and why should you use it inside your applications, and then we're also going to talk about how it's really going to help us to find all those concurrency issues and test them. So my name is Tamir Dresher. I'm an architect and a consultant from Israel. I work at a company called Code Value. My Twitter handle is written above, and please follow me. As well as other ways to contact me. So inside Code Value, we do a lot of consulting, and one of the things we also develop is a tool called OzCode. OzCode is an extension for Visual Studio. It's a debugging extension that makes a lot of debugging tasks much simpler and easier, and maybe we'll see it as part of the demos that I'll do. I'm also the author of the book Reactive Extensions in .NET, RX.NET in Action, published by Manning. And it is a book I published after a lot of years that there wasn't really a good book and a good introduction about what is reactive extensions and cases and patterns of using it. I'm also teaching software engineering at the Rupin Academic Center in Israel. And I talk at a lot of conferences. Most of the conferences I talk in is conferences about development, software development. So we're going to do a little introduction about reactive extension, and then I'm going to discuss about the concurrency model inside reactive extensions. And at the end, I'm going to show you how you can test concurrency issues and asynchronous operation with reactive extension. So if I need to just describe what reactive extension is in one sentence, I would say that reactive extension is like the headache relief pill that you want to use when you have asynchronous event processing and event-based application. And the reason for that is that reactive extension kind of modeled this world of reactiveness and events in what we call the push model, where a significant or some kind of event that is happening is flowing inside your application into a pipeline that does all kind of operation. And we say that this is the propagation of change. And the best way to describe what I mean by propagation of change is what you probably know from Excel or another spreadsheet that you're using. In Excel or spreadsheets, when you type something inside a column or a cell, and you have other cells that depend on the values, immediately it just changes. And if I will have another type of cell that does something on the value of the calculated cell, like the sum and the average, it will also affect the other cell. So we have this kind of a chain, we have kind of a pipeline of a single change in one place, let's say this column, is propagated to other cells inside this application. So just imagine your application and how it needs to react to changes that are happening. It can be something inside the application, like a state that changed inside the application, or some external notification that you got from an external system. And you would want the things that depend on that change to react immediately and in an effective way. So let's look at an example. Let's say we need to create a type of application that does searches. My application will get a hash code or some term, search term, and we'll go to Facebook, Twitter, LinkedIn, and we'll search for values in those systems. So the traditional way that developers are writing this kind of code is something like that. We have a method that gets the string of the hashtag. It will return some collection. In .NET, this type of collection is IEnumerable. In other languages, it could be iterable or other type of collections. And inside, we go and do a search in the Facebook, we get the results. Then we go to Twitter, we do the search and get the results. To LinkedIn, we get the results. And later, we just merge all the results together. And this code that is written in many type of application has a few flows inside. Basically, let's say that the time it takes to search inside Facebook is, let's say, 5 seconds. And inside Twitter and LinkedIn, it's a millisecond. So the moment that the user will see all the results will be when everything completed. We don't see the results immediately. So this makes the application less responsive. The user has typed something to search, and because one of the sources is slow, the entire search is slow. Even though I could have shown the result of Twitter and LinkedIn, because they are fast, much faster inside the application, but it doesn't happen. And it turns out that no matter how you play with this kind of code, just in this single method, you can't really make it reactive. You can't make it, as the way we know right now, something that will show the results immediately to the screen the moment something comes. You have to do a lot of work in order to get this kind of result. And Reactive Extension will give us the tools to take this simple code and just transform it in a single method to something that does this kind of immediate reaction based on the time of each of the components do their work. Basically, we're going to achieve something like that. The moment I get to Facebook and get results, it will propagate into the application and in Twitter and in LinkedIn. But the problem is that we don't really know what to write here. What is the type that needs to return to the application, to the code that uses this method in order to achieve this kind of reactiveness. So inside .NET and in other languages right now, we have a new kind of interface, which is actually pretty old because it's been there for a long time, but nobody really took the time to look at, which is called the iObservable. And iObservable is something that describes the source of the events, the source of the changes. So instead of enumerable that describe a collection of some type, iObservable describe kind of a producer of values. And this producer is generic, so it can be of any type that I want. And it only has a single method called subscribe. And I will talk about what subscribe really means in a moment. On the other side of this equation, we have the observer. And the observer is the consumer. It's the one that wants to receive this notification. It wants to receive the values that the producer produces at some point of time. Unlike collection, that is a static type of repository, when we talk about observable, we have a notion of time, because I don't know when the producer is going to produce time. I don't know when I'm going to get a sensor notification from something that is attached to my system or from an external system that will send something to me at some point of time. Both of those interfaces in .NET have been there for a very long time under the system namespaces, and Reactive Extension that based on those interfaces has been adopted in many other types of technologies. We have Reactive Extension for JavaScript, for Java, and for almost any language that you are using today. And between the two, we have a very special relationship, which goes like this. The observable is, like I said, is the producer. The observer is the consumer of the values. So the first thing that happens is that something inside my application is subscribing the observer to this observable, okay, by calling the subscribe method and passing the observer. Once that happened, we'll get back some object, which we call the subscription, and it implements the interface iDisposable, meaning that at any moment in time I can dispose this subscription and thus disconnect this relationship between the observable and the observer. This is really, really good for us because it kind of eliminates a lot of resource leaking that we might have in applications that are event-based, that something was attached to an event but never unsubscribed from that event, and then we get resource leaks. Because I have an object which is iDisposable, and I can put this object inside some variable, some member, I can always go and just unsubscribe simply by disposing this object. So once we have this attachment between the observable and the observable can start to emit values to the observer. And it does that by calling its method. Visually, we like to show a diagram, which we call the marble diagram, where the observable looks like a line. And now, when the observable got something to emit, some value, it will call the onNext method of the observer, and we show it on the diagram by some marble with the value. And it can do it one time, it can do it many times, it can do it no time, If the observable never has something to emit, that's okay as well. And once the observable is finished, it can call to the observer onCompleted method, and that way it signals to the observable, that's it, I have no more values to give you. This will also give us the benefit of resource allocation, because once it's completed, it disconnects the observer. So we won't get attached to an event that won't produce any values in the future. And because something bad might happen while the application is running, the observable can also signal the observer that an error has happened and passing the exception. In this case as well, once we have an error, the observer will be disconnected from the observable and all resources will be allocated and remain in our application for no need. And to show the way that the error is produced, we simply mark it as an X on the line of the observable in the diagram. Okay, so this is the basic of what is observables. Now, the reason we have reactive extension is that in order to work with those kind of things, we don't want to write code over and over again. So reactive extension is a package, and inside Visual Studio and .NET, we have the package manager. All the things, all the code, the utilities that are related to reactive extension are under the package system.reactive. And this kind of library, this package, give me all the utilities like factories to create observables and all kind of operators to work on the observable, which I'll describe in a moment. So let's go back to the example I showed you before of the application that needs to do searches in all kind of social networking sources like Facebook and Twitter. So if I need to write an application with reactive extension now, I will have my method. Instead of load messages, I call it observe messages because I don't know when exactly will I receive the messages. Again, I'm passing the string, but now I'm returning the observable of the messages, which give me the ability to subscribe and receive those kind of values. In the application itself, I can create my reactive social network manager. This is the class with the method. And now I can go and call the method observe messages, passing the value, let's say RX. And I subscribe to the observable. And this subscribe overload, this method, is what I got from reactive extension package, from the system.reactive library. It allows me to just pass the function of what I want to do whenever something happened. So the first line you see here is the onNext method, meaning whenever there's a value from the observable of the search, I want to just print it on the screen. Just say I got the value. If I get an exception, I can just go and do something with that exception. And if it's completed, I do something with the completion. So now, all the things that are related to this asynchronous event processing is written in the same block of code. It's not spread inside my application. It's really efficient from the resource utilization, because if something bad happened, it just detach. And the application that is doing this call is not blocked. Because observable can be asynchronous, it means that I can do the search. I don't know when I'm going to get the values, but my application is not blocked. It can continue its execution. Maybe it will show some progress on the screen. And once I got values, I'm simply going to write it. So we get a much better experience for the user, because unlike enumerables and collection, which I must block until I get the entire collection back, with observable, my code can continue running, and when the values will appear in an asynchronous way, I'm going to get the values and just do what I want to do with them. Very like callbacks that we might have in code. Okay, so all the theory of how to create observable is out of the scope of this session. If you are interested, you can look at my other presentation, which are available online. But just to give you a simple glimpse, I can do creation of observable in multiple ways. In the most simplest way, I can just say that on the observable static class, which I got from Reactive Extension library, I can say, give me a range of values and subscribe if I want. And this will create kind of like a collection of the 10 values, only are going to be in a push model. They are going to push to the observer. But because observable also have the notion of time, I can create this kind of an observable sequence by time by using the interval operator. And in this case, I will create observable that will emit a value by the time span I'm giving here, which means that every second I will get a value. This will allow me to create this kind of a building block to create other type of observables that do something. Let's say every second I want to go and do some operation to check some state, take the state, pass it on. And the subscriber, which is the observable, will just print it on screen, but I can do all kind of meaningful ways, like showing an alert to the user if something bad happened. And the nice thing is that all the code is in the same block. It's not spread like events on multiple places in my code. And the example I'm going to show you in a moment is of using the from event pattern, because in many languages we already have events. They are just not easy or efficient to use. So observables and reactive extension give me the ability to take an existing event, no matter what languages you use, and just create an observable from it, which means in this case I have a text box, which I call the search box, and I have an event inside called the text change. Every time the text changes, my observable that is created from this method will emit a value that will say the text has changed, the text has changed. So now I can subscribe to those changes. So all this is nice and well, but I'm sure you still don't really know or understand where is the benefit from it. So now I'm going to show you. So the real benefit from Reactive Extension is the operators that it provides. And this is just my kind of attempt to give you this grouping of all those operators. An operator is something that gives me some functionality on the chain of the events. And I have many types. I have filtering and projection and joins, but the really interesting part, which is the really one I'm concentrating in this session, is the time and concurrency. Because I can do all kind of operation and filtering based on time. This is something you won't get from simple collections. So now I'm going to create this kind of pipeline of all the operators that give me some meaningful value. So let's look at an example. Let's say I want to create this kind of application. This application will have a text box, and while I'm typing in the text box some values, I want to show to the user the research result immediately. Okay, this is something really common in application. The gotchas in this kind of application is this kind of rule that I have. For starter, I want to have at least 3 characters before I do a search. I don't want to search short words. I don't want to overflow the server, the search server, meaning that if the user is typing really fast, something really long, I don't want to search each character that it types. I want to have a delay of half a second before I'm going to do the real search. And if in this half a second interval it does another typing, then I just discard the previous one and do the new one. I don't want to search the same string twice. So if the user types something, deleted the value, and then type the same again, I want to just ignore this new value that he typed. And one thing that it really hard to do in traditional way of programming is that if I already doing a search, I already sent the search to the server, and the server is taking the time to search, and another search is coming because the user continue to type, I don't want to take the result from the previous search and display it. I want the new results to appear. Because imagine the case that you are typing something and the search is doing its way to the server, and the user then types something else, and he gets the results of the second search before the result of the first search. And now the first search results has come. If I'm going to show them on the screen, I'm going to show false information to the user because they search a new term. And this is something, in order to do that, if you think of your applications, you have to do a lot of timers to calculate the time and hold the state inside your classes. But instead, I'm going to show you that with Reactive Extension, it's really easy to do and much more readable. So let's look at the example. So in order to show you what's going on in the background, I'm going to show you Fiddler. And Fiddler, for those of you who don't know, is a sniffer. It's an HTTP sniffer. So every search that I'm going to do to the server is going to appear inside my Fiddler session over here. Okay, so let me just run it. Okay. So, clean this up. Okay, so like I said, I don't want to search short words. So let's say I'm writing the word, the letter R, and nothing is happening. You can see that in the Fiddler it's still empty. And I'm going to type another letter, still nothing. And then I'm going to type the third, and you see now that something was sent to the server. And you can even see the search that I sent to the server by this value over here. And so now let's type something really, really fast. And like I said, if I'm typing something fast, I don't want to search for each one of the letters, just the last one. So I'm going to type here something like the word reactive. And you see that only when I stop typing, it really sent the value, right? And okay, so let's look at the code and I'll explain what I did over there. So that's the entire code of this example. Everybody can see what is written? Okay, so let me explain what we see over here. Okay, so it all starts by creating an observable. And like I said, to create an observable, there are multiple ways. And in this little application, because I have a text box on the screen, I can just take the text box and just connect to the text changed event. And this will create me my observable. Now, because Reactive Extension is very much like Link, for those of you who know Link from .NET or maybe other type of application technologies, it will give me all kind of operators to work like kind of like SQL language. So in here, what I'm doing is that every time my observable emit a value, I'm going to select the value from the text box. I'm going to take the text that is inside the text box. So now these two lines created an observable of the text inside the text box each time it changes. So just by these two lines of code, I'm going to receive this text every time it changes. Then I added the where operator, and the where operator does a filtering. So I got the text that was emitted by the observable, and I'm just checking that the length of this text is at least 3 characters. Okay, so this by now we know. This is much more complex. So the throttle operator is an operator that based on the time that I sent over here, which is half a second, I'm saying that if something has changed, I got another value from the observable in a half a second, I'm going to dismiss the previous value that I got and just concentrate on the new one. So this gives me the ability that if the user types really, really fast, I'm only going to respond to the last value that it typed. Because if he waited half a second, this will be permitted to move on the pipeline, next on the pipeline. The distinct until change means that I don't want to search the same value twice, so wait for the value, and if the value is the same as the previous one, just drop it. So this way, no matter what was allowed to proceed from this chain, only if the value is not the same as the previous one, it will allow to continue. Now, I'm doing the real search. If everything was okay up to this point, I got a value that I really need to search, I'm going to send it to my search method, and this method is asynchronous. It returns something in .NET, we call it a task. In other type of technologies, it is called the future, which means this is a computation which the value will be available once it's completed in an asynchronous way. It doesn't block my application. The switch is not like switch that you know from programming languages of switch case. Switch simply means that if I got a value and I'm doing the search, and another value came and I'm doing the search for this value, then switch to this one. Okay. And then I'm going to go back to the UI thread to do the search. And at the end, I'm just subscribing, meaning that once everything went on the chain and I got the values back from the server, I simply want to show them on the screen. So this, about 10 lines of code, created a full application to do the search without the search server itself in a way that is readable for us human beings. And if tomorrow I have a new requirements that I need to add, it will simply mean to add another operator on this chain to do a new filtering or to do another type of logic inside. Okay, so I hope that now we all understand the value that reactive extension can give. So now let's talk about the concurrency model in reactive extension. So in reactive extension, we have the notion of scheduler. And the scheduler is kind of a unit that has a clock and it has a computation location. Computation location can be another thread or another task or another machine or another something. Which means that when I give it the job to do, when the time comes to do this job by the due time that I gave, it will pass it to the computation location and do this kind of operation. And it all boils to this kind of interface. And this interface called the iScheduler holds the property now, which gives me the clock, and all kind of methods to do the scheduling. So basically now I have an abstraction of this time and concurrency model, meaning that I can do any place that does a computation and any type of clock, for my case, to do this kind of operations. And once my application knows how to work with this kind of abstraction, I can give an implementation for my testing environment. So now all the operators inside reactive extension that introduce concurrency and has the notion of time, like the throttle is the operator we saw that discard items if they are not in the time span. It needs to know where to do this kind of time-based operation, how to run the timer. And it does it by using the scheduler. And so the example I showed you before could have been written like this, right? I just pass the scheduler to run my throttling on the default one, and I can later say where I want to receive the results on what kind of thread or what kind of concurrency item. So in our case, we showed that we can use the dispatcher. Dispatcher is the UI thread for .NET environment. And because it's something that we use a lot, we have a short operator just called observe on dispatcher. Give me the results on the UI thread. So to work with that now and do testing, we need to understand that time eventually is simply a sequence of values. Okay? Time by itself is kind of an observable. So everything that I can look at it as a sequential value, which is comparable, can be a time in my application, which give me the ability to create this kind of scheduler that I receive from the reactive extension package called the virtual time scheduler. And it will receive what is the type of time that we have. Specifically, a test scheduler that implements it is looking at time as a long value. So if I have the value 1 and the value 2, I can say that in the time range, the 2 came after 1. How much time it really took, it's irrelevant. It's how I describe time in my application. So let's look how can we test our X code with that kind of scheduling. So basically, what I want to show you that all the things that we do up now with the search application, I can describe as test cases, right? To search at least 3 characters means that I need to have a test. Let's say if I'm typing a 1-letter word, I don't want to do searches. And if I want to discard result if another was requested, I have a search test. I have a test case of 2 words with a 1-second gap. Slow first search, the second one is search. I only want to see the result of the second one. So how can we do this kind of unit testing in our application? It's not that easy, but with reactive extension, it's a lot easier to do. But we have a few questions that we need to answer. First of all, so how can we really test the code without the real user interaction? Because I have a search box. How do I kind of virtualize that interaction? And for that, I'm going to do a separation of concerns, and I'm going to do mock of the user. How can we test the code without a real server? Again, I'm going to refactor my code to allow dependency injection to inject a mock of the server. And to deterministically to do a search without a real asynchronicity and a real time, I'm going to use the test scheduler, and I'm going to inject it into my code. Okay, so if before we had this kind of application where we had the search view, right? I wrote everything inside my view class. I'm going to separate it into a search view that does only the presentation and a SearchViewModel which do which does the search logic and holds the state. So it will look something like that. This is my UI. It only has the presentation, the text box and the list box of the results. And I have my SearchViewModel, which is implement something to signal about the changes that are happening inside the code. And I'm having a property of the search term that I want to use, and I have the search results. And between the view and my view model, I'm doing a binding. So my search box, my text box, is bound to the search term, to this property. And the search results is bound to the item source of the search results, which is this one. So now I can separate the way I'm implementing each side. So now I'm taking all the code that we saw before, and I'm moving it right now to my view model. And now I'm saying that I want to take the property, the event that I have inside my view model, that every time the property changes, I want to know. And I'm creating an observable from it using the from event pattern. And like before, I want to do the search for only 3 characters, and all the rest of this code is the same as we did before. The only change now is that the results are going into my property of my object and not directly into the list box that I have on the screen. The second part is that I want to pass the search client, the one that is interacting with the server. So my search service client is now implementing an interface that I introduced, and now I can create mocks based on this interface. So now I can just write a simple kind of a test case. In this case, that if it's a 1-letter word, I don't want to do any searches. And to do that, I'm creating a fake. I created a mock of this interface, and this is using the end substitute package. So this just gives me a fake, nothing really special. Next, I'm creating my search view model. I'm passing the mock of my search client, and I'm changing the search term inside my view model into the letter A. So now, inside the view model, the notify property change, the event that says that something changed, is raised, and my code begins its working inside the view model. The only thing I want to make sure is to assert that the fake service client did not receive a call to the search async with the value A. And if this test passes, it means that my logic is correct. So this is a simple test, nothing too fancy. Unfortunately, we will have a few problems with the code as it is written, because it still didn't provide my scheduling and my scheduler for abstracting the concurrency. So right now my code is doing something asynchronously. I have no control over it, and it tries to go back to the UI thread, which I don't have inside my test. So now what I'm going to do, I'm creating a wrapper on all these kind of concurrency types. Let's say time-based operation, task, thread, dispatcher, which is the UI thread. And I give my implementation for the real code that uses the real schedulers, but inside my testing, I can change it. So the code inside my view model now changes to receive the concurrency provider that I created and use it inside the code. So in the throttle method, in the throttle operator, I now pass the concurrency provider thread, because I want to do it on another thread. I don't want to block the UI. And I want to observe the results on the dispatcher thread. I want to go back to the UI to show the results. So this is the code, and it will work fine inside my real application. Inside my testing, I want to control and I want to change the way this concurrency works. So Reactive Extension gives me the package Reactive Testing, Microsoft Reactive Testing, with the base class Reactive Test that I can use. And it will give me all kinds of utilities to create this kind of mocks on time. So now, my test will look like this. This is the test case for if I have more than a 3-letter word and I have a half a second gap between the word, I want to validate that the search was sent to the server. To do that, like before, I'm creating the fake service client, and I'm creating a fake for my concurrency provider, and now I'm changing my concurrency provider to use my test scheduler, which means that my fake concurrency provider will return my test scheduler for every method that returns iScheduler, which means that in my testing, all the code inside my ViewModel that try to use my concurrency provider will receive my test scheduler. So I'm creating my SearchViewModel, and I'm passing all the fakes. And now I'm telling my test scheduler, start your time. And I'm doing a search term which is reactive. And now I can tell the test scheduler, advance the time by 1 second, half a second, sorry. To do that, I'm creating the manipulation, the transformation between the real time into ticks. And my test scheduler uses ticks as long. So I'm just advancing it by half a second, which will cause my code to really work. It doesn't a real half second, but in my code it behaves like it. And then I'm calling my fake service client, and I want to make sure that it received the search async method with the value that I gave. So now this code runs really, really fast, and it kind of abstract and kind of make it look like the real time has happened, and I can control the time. And when I run it, I can see that the test really passes, and in the demos that I will provide as a link to my GitHub repository, you can see other type of test cases that we can do. Because with the test scheduler, I can even say for each point of time, what is the value that I want to receive. I can create a test scheduler that really say for each point of time what should happen. And so in my code, I can go and create in a way that the fake service client, when the word first is being searched, I want it to return the code observable, which will give me in the time of 2 seconds, I want it to return these values. And I want that when the second word, which is called second, happens, I want it to return something at the time of 1, which is like immediately return the result. So now I created kind of a service search client that does the search, one is slow and one is fast. And now I just run my code and I say, search the word first and advance the time by 1 second, search the term second and advance the time by 5 seconds. It runs really, really fast. It behaves like it's really running with a 5-second time span. And later I just make sure that my result is of the second search. Okay? Okay, so to summarize, because we don't have a lot of time, we saw what is reactive extension and how it can simplify kind of development tasks that we have. And based on the concurrency model that we have with reactive extension, it makes it easy to us to control time in testing, and not only to achieve better development cycle in our application and not introducing new bugs. So I'd like to thank you all. And if you're interested in reactive extension, you can go look at my book. We have the Reactive Extension portal that introduces all the documentation for reactive extension in all the languages and technologies. And if you're interested in .NET, all the source code is open source. You can go and look at the code. It's really, really interesting project, and I hope you enjoyed. Thank you very much.